Hey, good morning. Calculus 2, area between curves, chapter 7.1, and I made up this problem. I like this problem. Notice my wording here, it says set up the integration. So I write problems like that. Usually the book doesn't. Usually the book wants you to go ahead and find the area, but I said set up the integration. So that means you set up the integral to get the area, but you don't have to do it. Because there is a lot of skill in setting that up. Anyway, and I'll ask you to do some too, of course. You have to do some integration. But this question says, set up the integration to find the area of the region bounded by these curves. So I made up this problem. And you need a picture of it. So I'll try to sketch a picture of this. And that's what you need. And so maybe a graphing calculator is helpful. Although students tend to make a mistake sometimes, so I want to show you a couple things. So I need to get a sketch of this. Y equals x is very easy. That's this line, y equals x. And then this other thing is, let's see, if I solved for y, let's see, hang on. If I solved for x, I'd have x equals, I'd add the x, I'd have x equals y squared minus 6. And that's a sideways parabola that's, comes over here at -6 and opens this way. Yeah, that's what it is. What happens to students who use a graphing calculator, I just want to point out, they'll solve for y, which we might need to do anyway. If you solve for y, let's see, you add the 6 over there and you take the square root. So you get y equals the square root of x plus 6. Did you catch that? I added the 6 over there and I just took the square root of both sides to solve for y. And I made the classic mistake students make. What did I do wrong? I didn't put plus or minus. So what that picture is, a sideways parabola, the top half is the positive square root, and the negative half, the bottom half is the negative square root. So when you solve for y, it is plus or minus, and it's really two different functions of x. The top half of the parabola being the positive square root, the bottom half of the parabola being the negative square root. So, cool. I need those ideas. And a lot of students they'll forget the plus and minus, and then they'll use their graphing calculator, and so they'll never sketch this bottom half. And without sketching that bottom half, they try to find this area, or some, I don't know, they get confused. It's wrong. So, plus and minus is important. You know what else I think is important is finding these points of intersection. You know, if you do have a graphing calculator, sometimes you can just play around and find them. And then you got to trust it. Can you just see it and trust it? You know, it's better to probably do the math. To find the points of intersection, I think I would set these equal to each other. And that means you could set this y equal to this y. But then you got a square root, and you're going to have to square both sides and solve for x. I'd rather set this x equal to this x. So if I'm finding points of intersection, I'm setting this x, the parabola, y squared minus 6, equal to the other x, which is the line, y, and I'm going to solve for y. So I find these points of intersection. I'll write that. Points of intersection. And what do I do? It's a quadratic. I should move this y over. Negative y minus 6 equals 0. I think it factors nicely. Y minus 3, y plus 2 equals 0. So I get a couple answers. I get y equals 3 and y equals -2. Those are the y values of the points of intersection. I can plug them back in to get the x values. Remember, this is an easy equation, this line here. When y equals 3, x equals 3. So that's the point 3, 3. That must be this point right here. When x equals 3, y equals 3. That's the point 3, 3. When y equals -2, when y equals -2, x equals, where am I? Oh, x is -2, right. When y is -2, x is -2. So that must be this point here, -2, -2. So I want to find this area, the area bounded by the line and the parabola. And I've done a lot of work here. I needed those points of intersection. I've got this labeled as a -6 here. And I need to set this up. And my question is to set it up with respect to x and with respect to y. And some students get confused what that means. In my previous video, I tried to say if you're doing it with respect to x, that means the variables are in x's. If everything's in x's, the functions are solved for y in terms of x. Everything's in x's, and that means you're doing top minus bottom. You're doing top minus bottom. Basically, your rectangles are dx. If you're doing it with respect to y, your rectangles are dy, and you're doing a sideways subtraction. You're doing right minus left, and you're doing everything in y's. So that's what we mean by the phrase with respect to x, with respect to y. So I want you to set it up both ways. And can you tell which is the easier way? Pause, answer. To me, I can very clearly see a clear right curve and a clear left curve. If I had a rectangle running right to left, left to right, whatever, I just arbitrarily drew it there. I could draw it there. I could draw it anywhere. I clearly have this curve on the right and this curve on the left. So one right and one left, that's with respect to y, that would be the easiest integral to set up. Let's just do it real quick. Setting it up with respect to y, the right curve is this curve called y equals x, but we solve for x in terms of y. We call that curve x equals y minus the parabola here, which is x equals, there it is, x equals y squared minus 6. So it's the right curve, function of y, minus the left curve function of y with respect to y, and then I need y bounds. Those rectangles are going to move from a lowest y bound of -2 to a highest y bound of 3. I said 3. So that was the easiest setup, and that was the easiest thing to do, although you have to work with y's, which tends to bother students sometimes. They like to work with x's. Let's talk about that. I'm going to erase this rectangle because if I'm working with x's, I'm doing top minus bottom, and I see an issue, I see a problem, and hopefully you see it. The way I talk usually is I try to say, oh, there's one nice function on top, but to get this area of this whole region, there's actually two functions on the bottom. For a while, it's that bottom parabola, and then it turns into that bottom line. So I have two bottoms. I have one top and two bottoms, and guess what? That means you kind of got to slice it in half, and you got to do two different regions, and you got to do two different integrals. So it's a little bit more of a setup, and it's a little bit more to work on and to do. So again, if you had your choice, there you go. That's the easiest integral to do. That's the easiest integral to set up. And setting it up with respect to x takes more work, but we force you to do it. We ask you to do it. So maybe you see what I'm talking about. Yeah, I have to split this right here. I have to split this right here because if I have a rectangle over here, I can clearly see a top and a bottom. The top is the positive square root. The bottom is the negative square root. But over here, if I drew a rectangle, it is the same top curve, the positive square root, but a new bottom curve, the line, y equals x. So I think I'll set that up. I'll have one integral, and then I'll add it to another integral. I'll have two integrals. Let's see, the first integral I think would be this one, and what did I say? The top is this function solved in terms of x, solved for y in terms of x. It's the positive square root of x plus 6 minus the bottom curve, which is the negative square root of x plus 6 with respect to x. Now I like to set these up and show you the steps, and I don't really care about simplifying them, but the truth is that square root minus that negative square root, that's the top minus the bottom. That adds up to 2 of those square roots. 2 of those square roots. What are the bounds for that part of the region? The bounds are x bounds this time instead of y bounds like they were before. X bounds, which are -6 to -2, I think we decided. That's where I'm going to change and do my second integral. From -6 to -2 for that first integral. And then let's go ahead and do the bounds for this next integral. -2 to 3, I guess. -2 to 3. It's a different -2 and 3. -2 to 3 on the x values, and it's top minus bottom. And the top is the same old top, square root of x plus 6, minus the bottom, which is now the line y equals x with respect to x. Yeah, man, that's good. And the question was set up the integration, and you don't even have to do any simplifying, so this is a good answer for me on a Smith kind of question. Your homework probably asks you to do these. Sometimes your homework says set up both of these and then do the easier one. I don't really care about doing either one. I think you can do it. Are you curious? Do you want me to find the answer? On your mark, get set, go. I'll race you to the answer. To do the answer, I would integrate this. I kind of ran out of room here, but I'm going to do it. Integrate a y, you get 1/2 y squared. Integrate that negative y squared, you get a -1/3 y cubed. Integrate that well, wait a minute, that's a +6. When you integrate it, it's a +6y. You're going to evaluate from -2 to 3. From -2 to 3, yeah, this takes a little work. Plug in the 3. I'm going to get 9/2 minus 9 plus 18 minus, plug in the -2, 2, -8/3, no, +8/3, and -12. Wow. What is that? What is that? What is that? Come on, pick up a calculator, help me. Remember, you're trying to beat me anyway. What is that? That's 9/2 plus 9 minus 8/3 minus 10 plus 10. It's a -10, but I'm subtracting it. Yeah, that's interesting. That's 19 plus 4.5. That's 23.5 minus this 2 2/3. That's not the way to do it, but so now I'm at I'm subtracting 2/3. Wow, I think I get 20 5/6. Or 125/6. Or 20.833333, I think is what that is. So there, I did it without my calculator, sorry. So I could have made a mistake, but I'd probably beat you. All right, thanks, man. Work hard. Try these problems take some work. The setup is one issue, and then doing an integral is a little issue. Try not to make any mistakes. Be thorough and good. All right, thank you.